So we're going to solve quadratic equations. And remember, a quadratic equation has the form ax squared plus bx plus c. Highest power is x squared. Okay? When we solve a quadratic equation, the solution to that is often referred to many different names. Sometimes it's called a solution. Sometimes it's called the roots. That's also a solution. Sometimes it's called the x-intercepts. So the x-intercepts on a graph are the solutions to a quadratic equation. Sometimes they're called zeros. Okay? So they're called all sorts of different things. Okay? Solutions, roots, intercepts, and zeros. So if you're looking at a graph, the solutions to a quadratic equation are really easy. They're just the x-intercepts. So on this graph right here, there are two solutions. They're the x-intercepts. So one solution is -1, 0, and the other solution is 3, 0. The x-intercepts. So go ahead and write down. So remember, these are solutions, but we also know them as x-intercepts. So go ahead and find the solutions of this quadratic equation. Go ahead and write down what you think the solutions or the x-intercepts are of this quadratic equation. So here we also have two solutions, one at -4, 0, and one at 1, 0. Right? So the x-intercepts are the solutions. So on a graph, it's a piece of cake, right? It's just the x-intercepts. But what we're going to look at now is what happens if we don't have a graph? What if we just have an equation? How do we find the solutions, i.e. the x-intercepts? Okay? And there's two methods we're going to use today. We've done both of them before, but we're going to review both of them. And the biggest thing is trying to figure out which method you're going to use. Okay, so I'm going to kind of show you how you're going to decide which method, and then we'll go through both methods. Okay, so the first method is using factoring. And you're going to use this when you have x squared and x in your equation. So if you have x squared and x terms in your equation, that's how you'll know if you want to use factoring. So I want you just to look at these 4 problems here on the front page. For problem number 1, do we have an x squared and an x in this equation? Is there an x squared and an x? Yeah. Yes. How about this one? An x squared and an x? Yep. This one an x squared and an x? And this one an x squared and an x. So these are all going to be, we're going to use factoring on all of these on this page. Okay? Flip your page over. Does this equation have an x squared and an x? No, it just has an x squared. Does this equation have an x squared and an x? No, it just has an x squared, right? So if it's only an x squared, we're going to use this other method called square roots, which we'll do at the end. We'll come back to that later. Okay, does that make sense though? How you're going to decide which method you choose? So for the factoring, you will do that whenever you have an x squared and an x term, both of them. Okay? So there's basically 3 steps here. 1, you want to make sure your quadratic is equal to 0 before you even start this method. So out of these 4 problems, which ones are already ready to go? They're already equal to 0. Which ones are already equal to 0? Yeah, sorry, go back to the front page. I guess I didn't say it. The first one is already equal to 0, and the 4th one, right? These 2 are not equal to 0, so we'll have to make sure those are equal to 0 before we start. So that's the first thing. You want to make sure it's equal to 0. Once it's equal to 0, there's 2 steps. You're going to factor, and then you're going to set both factors equal to 0 and solve. So we've done this before, okay, but not necessarily in this exact occasion. So number 1 here is already equal to 0. This part is already done. So step 1 is to factor. So we're going to factor this into two binomials. Because this is a trinomial with a equals 1, we're just looking for two numbers that multiply together to get -6 and add together to get -1. What would be our numbers that multiply together to get -6 and add together to get -1? Sorry, I think you're looking at a different one. -3 and 2. -3 and 2. Those will multiply together to get -6 and add together to get -1. So this will be x minus 3 and x plus 2. Because our equation is equal to 0, the last step here, step 2, is to solve for x by setting both binomials equal to 0. So both factors equal to 0. So we'll set x minus 3 equal to 0, and we'll set x plus 2 equal to 0. We'll solve both of those equations. This one will add 3 to both sides, and we'll get x equals 3. And this one will subtract 2, and we get x equals -2. So all you have to do is make sure it's equal to 0, factor it, and set those factors equal to 0. And that will give you two solutions for this problem, okay? So we do want to write our answers as ordered pairs, though, because remember they're x-intercepts, right? What we just found here really are the x-intercepts. We didn't have a graph, but we used our factoring to find those x-intercepts. So our answers, we're going to write them as ordered pairs. As x-intercepts, it's 3, 0. And -2, 0, because remember, x-intercepts always have the y as 0, right? That's what you're finding. You're finding the zeros. That's why we also call them zeros sometimes. X-intercepts, zeros, solutions. This is going to be our final answer here. Any questions on number 1? All right, let's do number 2. Is this one equal to 0? Is this one equal to 0? No. So we need to make sure it's equal to 0. Whenever you make it equal to 0, make sure you move everything to the side where the x squared is, okay? So here the x squared's over here. So we'll move the 24 over there. How will I move the 24 over there? Subtract. So I will just have x squared minus 5x minus 24. And then I'll have a 0 over here. Don't lose your 0. Don't forget your 0. It still needs to be on the other side. That's going to remind you what to do in a little bit. Once it's equal to 0, you're going to factor and then set both factors equal to 0. So I'd like you to finish this one. So factor. This is a trinomial with a equals 1. So you're just looking for two numbers that multiply together to get -24. Add together to get -5. So go ahead and try to finish this one all the way. Try to get all the way down to the answer on your own. So we looked for two numbers that multiply together to get -24, add together to get -5. We found that was x minus 8 and x plus 3. So we take both of those factors, set them equal to 0, and solve. But most of the time, you might see your answers like this sometimes, but I want you to get into a good habit of writing them as x-intercepts, right? These solutions are the x-intercepts. So this guy has two x-intercepts here, one at 8, 0 and one at -3, 0. Those are also the solutions, right? So this is your solutions, 8, 0 and -3, 0. Any questions on that one? Okay, these next two are a little tricky, so we're going to do these two together. Okay, so this first one here, is it equal to 0? No, so we're going to move everything over to one side. Move it to the side where the x squared is. The x squared's over here. So let's move the 7 over here, and let's move the 7x over here. What would I do to move the 7? I'm going to subtract 7. It's a positive 7, so I'm going to subtract it. I'm going to put it underneath the 2 because those are like terms. And then what would I do to move the 7x? That I want to add because it's minus 7x, and I'm going to add that to the x term. So on the left-hand side, we'll have 0. because those will go away. Then we'll have 3x squared plus 6x when you do -1 plus 7. And then -2 minus 7 will be -9. Okay? Now we need to factor. But there's a problem with this one. Be careful. You cannot look for two numbers that multiply together to get -9 and add together to get 6. You cannot do that right now. Why not? There's a number in the front. Remember, when A is not 1, you cannot do that, right? So you have to use a different strategy. You could, there is one option. You could use the slide and divide or the grouping method, but this one actually is a little bit easier if we notice something first. If there's a GCF, you should pull that out first. Is there a GCF here in all three terms? What are all three of those terms divisible by? 3. So let's factor out a 3 in the front first. So we write it down in front, and then we write what's left in the parentheses. So we'll have an x squared left when we take 3 out of this. 6 divided by 3 will leave us with a 2x. And 9 divided by 3 will leave us with a -3. Now, is this a trinomial with a equals 1? Yeah, now this is a trinomial with a equals 1, right? Because there's a 1 in front of the x squared. So now you can look for two numbers that multiply together to get -3 and add together to get 2. Leave the 3 in the front. It's just going to hang out there. Those numbers are going to be, what, +3 and -1? +3 minus 1. And then we set our factors equal to 0. This one will give you x equals -3. This one will give you x equals 1. What about this 3, though, in the front? Do I need to set that equal to 0? The 3 in the front? I mean, I can try. What happens if you make 3 equal to 0? Is that even possible? Does 3 equal 0 ever? No, so that's not going to really affect any of your answers, right? Because it doesn't have an x in it. So then your two answers are going to be -3, 0, and 1, 0. It's not going to affect your zeros, right? It's not going to affect your solutions. Any questions on number 3? All right, last one, number 4. Is this one already equal to 0? Yeah, so this one's ready to go to factor, but I also cannot find two numbers that multiply together to get -6 and add together to get 1 here. Why can't I do that? There's a 2 in the front, right? That method doesn't work when there's a number in the front. Do I have a GCF I can factor out of all 3 of these terms this time? No. So now we're going to have to go use that long method, the grouping or the slide and the divide. So we're going to do one together because I know it's been a while since we've done that. So I'm going to remind you how to do the grouping method. If you like slide and divide, you're welcome to do slide and divide. So remember, the first thing we do is we take the number in the front and we multiply it by the number in the back. So 2 times -6 will be -12. And we look for two numbers that multiply together to get that number instead of this -6 and add together to get the middle number. Yes, yeah. So you take the number in the front, you multiply it by the number at the back, and this is the number. You're going to look for two numbers that multiply, and then you're still going to use the middle number for two numbers that add. So this is going to be 4 and -3. But I think the hardest part to remember here is that once you find those numbers, you can't go straight to your factors, right? That's usually what we do when it's a equals 1, but we can't do that here. Anyone remember what you do with these numbers when you have the number in the front? You put them in the middle so we can do grouping. Remember that? You got to put them in the middle so we can do grouping. So we keep the 2x squared the same at the beginning. We keep the minus 6 the same at the end. It's still equal to 0. But in the middle here, this 1x, we split it up into 4x minus 3x. Or if you do it the other way, it doesn't really matter which order you put it in. You'll get the right answer no matter what. But you take those two numbers. Remember, you split it up in the middle. And then we do our grouping because there's 4 terms. On the left-hand side, what common factor do I have with these 2 terms? 2x. 2 and an x, right? They both have an x as well. So 2x, we factor out the GCF and write what we have left. When I take a 2x out of this guy, I'm going to be left with just x. When I take a 2x out of this, I'm going to be left with just 2. What's my GCF on the right-hand side? What do these two have in common? Negative 3. Pull that out. We'll be left with an x. When you take a 3 out of 6, we're left with a 2. But because I pulled out the negative, what is that going to turn into? Plus 2. You did negative 6 divided by negative 3 is plus 2, which is good because remember, we want these two to match. Those two match. So one of your factors is x plus 2. The one that matches. And then your other factor is whatever's left. So what's left if I take out x plus 2? 2x minus 3. Now we can have factored, right? Because now we have the 2 parentheses. So what do we do once we factor? We set those equal to 0, right? Just like before. Set those equal to 0. This one you're probably actually going to have to solve out. You probably aren't going to be able to do that one in your head. How do I solve this equation? What am I going to have to do first? Add 3, then divide by 2. So here, x is equal to 3 halves. So we've got 2 answers here, negative 2, 0, and 3 halves, 0. So this kind of factoring is going to come back here in this unit, okay? So if you need to go back and review how to do that kind of factoring, we just did one together. It just involves grouping. If you want to use slide and divide, you can do slide and divide, but you will need to bring that back. Remember, that's when A is not 1, right? That's when you have to use that method, when A is not 1, okay? Any questions about this one? Usually it's going to be a fraction. Okay, now let's flip over to the other side and let's talk about this square root method. We've done this already before, so this should be a little bit of a review. But this is another way that we can solve quadratics, okay? And we're going to use this version, the square roots, when there's only an x squared. So if you don't have an x term, you're going to have to use square roots. So if you look at all of these, there's just an x squared. Even this one is just an x squared. There's no just plain x because this x is being squared here with that guy, okay? So none of those have an x squared and an x term. They're all just x squared. All you have to do with these is we're going to solve for x. So we're going to solve for x squared first and then solve for x. And we are just going to make sure we don't forget that plus or minus sign, okay? So we've done this a lot, but we're going to refresh on it right now. So right now, if I want to get x squared by itself, okay, I'm not going to start by taking the square root. I cannot square root until x squared is alone. So what am I going to do first to get x squared by itself? Add the 16. Don't divide by 4 first, okay? Get rid of the 16 first. So add 16 to both sides. That'll give us 4x squared equals 16. Now what can we do? Not yet. Square root can only happen when it's just x squared. First divide by 4. And now that the x squared is by itself, how do I get rid of the square? Square root both sides. But what can we not forget? We always have to have a plus or minus in front of that square root when we square root both sides. So that will make the square go away, and you'll just have an x on the left. And you'll have plus or minus the square root of 4 on the right. We're not done. I'm not done. Yeah, I'm just letting people catch up. What's the square root of 4? 2. So this is going to be x is equal to plus or minus 2. So how many answers do I still have for this problem? 2 answers, positive 2 and negative 2, just like the other one. I have 2 answers, 2, 0, and negative 2, 0. That's what that plus or minus means. I'm just going to get my 2 answers from the plus or minus instead of from my factoring, right? So you're still going to get 2 answers most of the time. There will be a couple times where you won't get 2. Any questions on number 5? All right, number 6. First, I want to isolate the x squared, get the x squared by itself. So I cannot square root yet. That's honestly one of the most common mistakes. People try to square root first. You cannot square root until it's just the square there, okay? So what should I do with that 2? Divide. So I have x squared equals 20. Now I can square root both sides. Don't forget your plus or minus in the front. All we'll have left on the left side is the x because the square root undoes the square. And then we'll have plus or minus the square root of 20. Last time our number was a perfect square. This time is 20 a perfect square? No. So we're going to have to simplify that, okay? Perfect square that divides 20 is 4. 4 times 5 is 20. So we'll have plus or minus the square root of 4 times the square root of 5. So this will be 2 square root of 5. Another reason why we reviewed radicals yesterday, simplifying radicals. So we have 2 answers again. Positive 2 radical 5 is one of our answers. And negative 2 radical 5 is our other answer. So we have 2 x-intercepts here, but these are not nice whole numbers. So remember those times where the x-intercepts crossed in between values? This is exactly one of those situations where it's going to be a nice not decimal, right? Our x-intercept is not going to be a nice whole number on the x-axis. Any questions on that one? All right, number 7. This one's a little funky looking. It's a little bit different because the squared is outside the parentheses here. So usually we try to get the x squared by itself, but this whole thing is squared. Can I go in here and add 2 to both sides first? That's what a lot of people try to do. Can I go in here and add 2 to both sides first? No, because the minus 2 is inside the parentheses. So you cannot go in there and add 2 first. This is one of those times where the square is already by itself, so we're going to have to get rid of that square first because it's on the outside. So how do I get rid of the square? Square root both sides. Don't forget your plus or minus in front of the square root. When I square root this side, that's going to cancel out the square, right? That cancels out the square, so what will I have left over on the left? Just x minus 2. That's all you're going to have left over there when you cancel out that square root. And then we'll have plus or minus the square root of 36. That is a perfect square, so that'll just be 6. And then this is a little interesting part here. People tend to just put plus or minus 6 as their answer. But is plus or minus 6 going to be our answer here? Are we done? No, we still have to get rid of that minus 2. So what I personally like to do, because I get confused by this whole plus or minus thing, I just make two separate equations. One with positive 6 and one with negative 6. That way I don't get confused by the plus or minus. That's what that means, right? One is positive 6 and one is negative 6. So then here you can add 2, and you'll get x equals 8. And here you can add 2, and you'll get x equals negative 4. So your answers will be 8, 0, and negative 4, 0. So if you get that plus or minus the number and you're not done, I would recommend making two equations out of it, just because it makes it less confusing and you don't do any silly mistakes. If you tried the last one, I'll tell you what the answer is on this one. We're not going to do this one all together right now, but it's going to be plus or minus 8i. This one's going to have imaginary solutions because you'll have a negative under the radical. So it actually is not going to have any x-intercepts here, because you can't have imaginary numbers on a graph. So this would be a situation where the graph does not have any x-intercepts. Homework's in the back if you want it. We will practice tomorrow.